Hello learners, welcome to the video lecture on subject heat and mass transfer. In this video session, we are going to discuss log mean temperature difference method for the analysis of heat exchanger. We know that heat exchanger analysis can be done by using two methods. One is known as the logarithmic mean temperature difference method, that is LMTD method, or another method is known as the number of transfer units, that is NTU method. In this LMTD method, the temperature difference between hot and cold fluid varies along the length of heat exchanger. As you can see in this graph is plotted between temperature along the area of the heat exchanger. We know that in case of parallel flow heat exchanger, initially the hot fluid having very high temperature, which goes on decreasing as the area or length of heat exchanger increases, and cold fluid temperature increases slowly as the area or length of heat exchanger increases. But if you want to determine the temperature at any point of heat exchanger, it is difficult to find out the value, and this value varies continuously along the length. So to determine the value of temperature at any point of location of hot as well as cold fluid, we can use this method. So in this method, a equation is derived known as Q is equal to UA theta m, where Q is the amount of heat transferred from hot fluid to the cold fluid. U is known as overall heat transfer coefficient. That factor we have already discussed in the previous session. And theta m is known as log mean temperature difference. So in this method we are going to determine the value of this theta 1. Now first of all I will explain this graph. This graph is for parallel flow heat exchanger. This arrow shows the direction of both the fluid. Here we are using subscripts as H for hot fluid, C for cold fluid, and subscript 1 and 2 refers to the inlet and outlet condition. Now we will apply this LMTD method for parallel flow heat exchanger. Let us apply this LMTD method for parallel flow heat exchanger. In introduction part we have discussed that in case of parallel flow heat exchanger, both hot as well as cold fluid moves in the same direction. So here you can see the direction of arrow, both are moving in the same direction. So here at initially theta 1 is nothing but the difference between inlet temperature of hot fluid and inlet temperature of the cold fluid, that is TH1 minus TC1. At outlet condition, theta 2 is known as TH2 minus TC2, that is the difference between outlet temperature of hot fluid and difference subtraction of temperature of outlet cold fluid. Now if you want to determine the temperature at any given point, we can use the formula Q is equal to UA theta m, where theta m is nothing but theta 2 minus theta 1 divided by log of theta 2 by theta 1, or theta 1 minus theta 2 divided by log of theta 1 by theta 2. Now how to determine this theta 1 and theta 2? I have shown here. Theta 1 is equal to TH1 minus TC1, that is the difference between the temperature of hot and cold fluid at inlet, and theta 2 is the difference between the temperature of hot and cold fluid at outlet, where theta m is called as LMTD. Similarly, we can apply the same method of LMTD in case of counter flow heat exchanger. We know that in case of counter flow heat exchanger, hot and cold fluid moves in the opposite direction. Here you can observe the arrow direction which is represented in the opposite direction. The formula of theta m is same, that is theta 2 minus theta 1 by ln of theta 2 by theta 1, as similar to the parallel flow heat exchanger, but the only difference is in the formula of theta 1 and theta 2. It is the major difference. Students should not get confused in this formula. Here theta 1 is equal to TH1 minus TC2 and theta 2 is equal to TH2 minus TC1. Only this is the small difference between the parallel and counter flow heat exchanger. Otherwise the formula of theta m is same. Thank you.